Hello. Well, I want to do an experiment for you. I want to react magnesium metal with hydrochloric acid to show you how reactive magnesium metal is. I've massed 0.25 grams of the magnesium metal. I don't know if you can see it. It's a very silvery, shiny metal. And that's magnesium ribbon. 0.25 grams in here. I've got 30 milliliters of hydrochloric acid. Now, the acid, as you probably have seen in movies maybe, acid reacts very vigorously sometimes with metals. And so I'm going to pour this in here. I've got it in a test tube. And what I want to do is get a reaction going between the magnesium and hydrochloric acid. Now, actually, what I want to know is when I'm going to form a new compound, you'll see a reaction. You'll see evidence of a chemical reaction going on right now as I pour the acid in. There we go. And I don't know if you can quite see that. Let me hold it this way. So there's some evidence of chemical reaction going on there. What do you see that would indicate to you that chemical reactions are occurring? Well, maybe we can get in close. Let's come over here, see if we can get in close. Maybe we can zoom in. It's kind of murky there. Turn it around. Swirl it up a little bit, mix it up. Back. All right. Messing with my camera here, just still learning how to use it. Oh, look. Well, let's see. Still got some going on there. Still have some right in here. Not as much. It looks like there's just one piece left. Seems like there's a lot of bubbling going on there. Now, what's happening is that those bubbles that are coming up there, that is producing hydrogen gas. So the hydrochloric acid, which has hydrogen in it, has hydrogen and chlorine. And the magnesium, which is a metal, an element, what happens is that magnesium undergoes a chemical change. And it loses 2 of its electrons to become magnesium with a positive 2 charge, or 2 plus charge. In the process, the hydrogen that's in the hydrochloric acid has a hydrogen with a plus 1 charge, and those electrons, an electron gets added to a hydrogen ion, this plus 1 charge, to give you hydrogen, the element. In fact, that's what we're seeing here. It's hydrogen gas coming off. Hydrogen gas. It's actually getting a little bit warm. So this is what we call an exothermic reaction. You can kind of see that there's condensation up along the sides of the test tube here. All right, it's bubbling. Still can see that piece of piece of magnesium right there. All right. And let's kind of shake it up a little bit. Now, I'm using 30 milliliters of acid, which I think should be enough acid to react all of this magnesium. However, I'm not completely certain that the concentration that was on the bottle is accurate. I might have to use more hydrochloric acid. I want to make sure all of that magnesium reacts. And I don't really want to add too much more hydrochloric acid because what I want to do is once I get this all reacted and all the magnesium will have essentially dissolved. Well, we say it's dissolved, but it's actually changed chemically. Actually, this is getting pretty warm now, where I'm holding it here. It's getting pretty hot. As it heats up, it seems like it reacts a little faster. The bubbles are coming up a little more quickly. So that'll help make the reaction go faster. So the magnesium will all react, become magnesium with a 2 plus ion charge on it, becomes what we call a magnesium ion. And the chloride, which is still in the water, or still with part of the acid, will combine. The chloride is negatively charged, and the magnesium is positively charged, the magnesium ion. And so opposite charges attract, so the magnesium ion will attract actually 2 chloride ions because the magnesium has 2 positive charges on it. Each chloride ion has 1 negative charge on it, so you'd need 2 of them. So we get a chemical compound that would have a formula of MgCl2. Mg stands for magnesium, Cl stands for chlorine, or chloride in this case. It's going a lot slower than I had hoped. I could have used a more concentrated acid. And maybe if I wanted to do this a little quicker, maybe I would want to use a more concentrated acid next time. All right. This one is fairly dilute, which means in 1 liter of this acid, there'd be 1 mole of the acid. And maybe I should have used something with like 3 moles of acid, because the more acid you have there, the faster it's going to react. At any rate, what I want to do is I want to get all that magnesium dissolved. When it's all dissolved in solution, I'm going to have a compound that will be magnesium chloride, and it will be dissolved in the water. Now, the hydrogen gas is bubbled away, and hydrochloric acid has hydrogen chloride and water, so there's going to be lots of water. And what I want to do is get rid of the water so that I can obtain the white compound that I have formed here, the magnesium chloride. And so that means I'll have to evaporate off the water. And that's why I'm trying to be careful about not using too much of the acid. But at this point, it's taking much longer than I thought and I hoped. And I would have to say I really want to go use a little bit more acid, or maybe stronger acid. So maybe add a little bit more acid to it. Not much. I'll try to measure out about 5 milliliters of acid. I don't want too much, but I want to make sure that all of this acid is, all of this magnesium reacts. Add a little bit more. This means I'll have a little bit more to evaporate off, which that's the unfortunate thing, is that it'll take a little bit longer to evaporate off all that water. So let's see here. It's going pretty good. Pretty warm. And so the idea here, when you actually write out the equation, if you write out the chemical equation for this, you're getting magnesium, Mg, and HCl. Those are your reactants. And they are forming hydrogen gas, which is H2, so it's H with the subscript 2, and magnesium chloride, MgCl subscript 2. So try writing that equation out while we're waiting for this. That would be Mg plus plus HCl, and then you draw an arrow going to your product, which will be MgCl2 subscript 2 plus H subscript 2. Now, those are your products. And it doesn't matter whether you go MgCl2 plus H2 subscript 2 or H subscript 2 plus MgCl2. The plus is really just means this and this. So we've got magnesium and HCl reacting to make MgCl2 and H2. Try balancing that equation, because right now I don't believe it's balanced. Balancing the equation means that you're going to be changing the coefficients, the numbers in front of those formulas. The way you have your equation written right now, and I'll give you a minute to write it. Say that again. It's you're going to write your equation, Mg plus HCl. Then draw an arrow. It's going to go to MgCl2, subscript 2, with a plus sign, meaning and H2. Let's see if we can get that to react. So, lesson one, when you're doing an experiment for the first time, and this is for the first time, you make notes about, this is taking a lot longer than I'd like. So what I want to do, if I were going to do this again, and I probably will do this again, is use a more concentrated acid that's stronger, that will react much faster with the HCl, or excuse me, with the magnesium, so that I don't have to wait as long. I mean, it's been almost 10 minutes, and we still haven't got it reacted, and we've got to wait and evaporate off that liquid. And that's going to take about 10 to 15 minutes. So first time through, when you're doing an experiment, you make notes of things that could be better if you were to do it next time. And I'd strongly like to encourage you. We would probably do this 2 or 3 times, just so that we finally get the hang of it and we can get consistent results. What I want to see is, I know how many grams of the magnesium I have. I have 0.25 grams of magnesium. And if I have that chemical balanced equation, which you just wrote down, Mg plus HCl, going to MgCl2 and H2, all right, the balanced chemical equation, all right, shows me that if I have 1 mole of magnesium, that it will produce, when it reacts with 2 moles of HCl, it will produce 1 mole of the magnesium chloride, MgCl2, and 1 mole of the hydrogen. So if I know I've got 0.25 grams of magnesium here, I know how many moles I put in here to begin with. Well, when I get rid of all this water, which, it's looking good, very little, just a little bit up here, a little bit of piece up here. Let's see if I can shake it up. If I get all the get rid of the water, then I'll have the magnesium chloride in here. I can get the mass of the magnesium chloride that I made. So I want to see, for the 0.25 grams of this, all right, I should be able to figure out, before we actually get the final result, how many grams I should be getting. That's called the theoretical yield. All right. How much I actually get will be what's in the test tube, which we call our actual yield. And I see that little bit of magnesium. It's just kind of frustrating there. Come on. All right. Sometimes pieces. I want to be sure. So let me add just a tad more hydrochloric acid. Yeah. We want to make sure that we get all of that magnesium reaction, because we had 0.25 grams of it, and we want all 0.25 grams of it to completely react. All right, let's see if we can mix it up a little bit. Now I'm kind of holding it with my hand up here, but I'm kind of just jabbing it, trying to mix it up. I still see bubbles there. What I'm looking for is evidence that the chemical reaction is common. Once I don't see any pieces of magnesium, and the other thing is that the bubbles kind of have all come out. Those bubbles there, the reason it's cloudy up here is because there's hydrogen, there's gas in the water. And you know how when you turn on your faucet, sometimes the water comes out fast. The water looks all cloudy, and then eventually it settles and it gets uncloudy, and that's because the gas, the dissolved air in the water, has risen to the top and come out. And doggone it, I see that piece of magnesium there, and it's just not going to give me a break. It's just about this big right now. Well, possible change of plans here. Well, now I think we're going to evaporate it. I don't feel really great about the fact that I'm about half. The test tube is about half full, and I want to evaporate this off. You'll kind of see the problem. I want to boil the water off. That water, I want to boil it off, but I don't want any to come out the top. That's where I'm going to have to be really careful. It's going to be kind of tricky. And so that looks pretty good. Looks clear. looks like you can't tell that there's something in the water or in the air. So let's go. Let's see if we can bring it over here. Set this up. Light my burner. Yep. Oh, well, I've got to turn on the gas. That would help. So, take my flame. I'm going to turn the barrel so that air can come in through the bottom of the barrel. The oxygen makes a hotter, richer burning flame. And this one, see here, it looks a little out of focus to me. There we go. Sharpen up my image a little bit. All right. So what I want to do is very carefully hold it above the flame, and just kind of move it in and out of the flame. I just want to heat it. I want to try to prevent it from splattering. This is going to take some time because that's quite a lot of liquid. And the trick is you kind of want to keep moving it around, stirring it around a little bit. I'm using test clamp here, test tube holder actually, to hold it. All right, kind of swirling it. You can kind of see the bubbles coming up. Now, this is the tricky part. You need to kind of evenly heat it. You don't want to heat one side or one area too much because you don't want to create a big gas bubble that might blow liquid out of the tube. Sort of like when you're boiling water. You got your water boiling really heavily, going strong. Sometimes you get these big bubbles that burst and liquid splashes out of the pot. Now, I have an alternative, another way I could have done this, and I chose not to do that because I wanted to kind of demonstrate how to evaporate off a liquid in a test tube using this technique slower. Another thing I might consider doing for the next time is using a beaker. A beaker has more surface area, and it will evaporate quicker. This test tube has a very small opening. The diameter of the test tube is not very small, so it takes a lot longer for the liquid to evaporate out. See that? So when it starts doing that, I've got to kind of just keep it. All right, keep it going. All right, you can see steam coming up, but that's what we're talking about. We're at near the boiling point right now. So part of why I wanted to do this, it's tricky, is to show you how to do it. Now, it would be much better, as I said, if I was doing this again, I would use a more concentrated acid, probably an acid that's 6 times stronger. When I say concentrated, it has instead of this 1 molar, which has 1 mole of hydrochloric acid in a liter of solution, I would use 6 moles of acid in 1 liter of solution. That would mean I'd have less liquid to work with to have to evaporate off. That would take me less time. The actual reaction would happen faster, and I wouldn't have to worry so much about having this boil over. That's what I'm trying to prevent. I got steam coming off here, but it's going to be a slow process. And I've got to keep my eye on the test tube. Ion. You know, keep your eye on the magnesium. Magnesium ion. Okay. So, yes. So, these are some of the things we determine as we do an experiment. We think about better ways, more efficient ways to do it. You know, the reason I like the test tube is that it's a very high very high, the glass. Oops. And so I would, hopefully, if I had less liquid in there, it would not splash out. With the beaker, they're a bit shorter in height, and so some of the magnesium chloride compound should be more likely that it might splash out. Now I'm holding my hand because actually getting pretty tiring. Pulling my shoulder like this. And oh! And that is what we have to be careful of. And in essence, we've kind of, our experiment has kind of gone down the tube. Well, actually, it came out of the tube. Because it's a bunch right here. So I've lost a bunch. So obviously, this is going to affect my final bit. So in essence, what I'd like to do is speed up this process, because we've already ruined the experiment, all right, by the fact that I had some splash out, is let's boil off just a little bit there. Let's take less. And because I want to show you that there is a compound in there. So that would be much better to work with. So let's see if we can boil off that liquid. And see, that's about what I'd want to use next time I do this experiment. About that much if I could get away with it. Because it's not as much to boil. So you can see steam coming out of this top here. So obviously I'm going to have to do this again if we're going to see what kind of results. I wanted to see what kind of percent yield I'd get. I wanted to see if I could actually show you that you could probably calculate the grams. But this time, at this point, what we want to do with this is demonstrate to you that the magnesium, the metal, the magnesium atoms are there in the liquid. That you have formed a compound. That all those bubbles that you saw, and the fact that I felt the test tube getting warm, it's heating up, that was coming, that was showing you that there was a chemical reaction happening. We're forming something new. And the magnesium, it's not like salt dissolving in water. I mean, salt is a white substance, right? And it dissolves in water, and you can't tell it's in the water until you boil off the water, then you see you have the white solid there. Well, the magnesium chloride is dissolved in the water. We can't see it because it's dissolved, but once you get rid of the water, then you can see the white solid. Hopefully it's probably a white solid, I suspect. Most salts are. This is magnesium chloride. Regular salt is sodium chloride. And, well, when I say regular salt, it's salt that we're most familiar with, that would be table salt. And I don't know if you can see quite yet, but there is some white residue showing up on the inside of the test tube. Kind of heat it up over here, kind of drive off that water that's up there. Get the test tube nice and hot, as I want to evaporate off the liquid. And again, even when you have a little bit here, you've got to be aware to move it in and out of the flame. Don't let it build up too much. My left arm is getting a good workout here. My shoulder, I feel it right here. Really good. I would switch to my other arm, but I'm not very good right-handed. All right, we're getting there. We're getting there. Almost. Oh, yeah. There we go. See if we can get up here and heat up the test tube. Get rid of that water that's up there. Moisture, condensation. The hot steam rises to the top of the test tube. The top of the test tube is a little cooler, so the hot steam condenses. And get that condensation there. Oh, that's looking good. Now I want to make sure it's good and hot, evaporating. And I'm going to come show you what it looks like. Right, there's my solid. There's the magnesium chloride. I It appears to be pretty hot. Let me bring it over to the camera. I'm not going to be careful. I'm going to be careful not to touch that. But that's the white solid. Let's see here. I'm standing behind it so you can see it. But that's the white solid. So there it is, the magnesium chloride. That's where the magnesium atoms are now. All right, they're now not just magnesium with zero charge, which is what the element would be, but there are magnesium atoms that have 2 positive charge on it, and they're attracted to, combined with, bonded with chloride ions to make this white salt. So, when this is done and cool, I'm going to mass this test tube. I already know the mass of the test tube. I want to mass the test tube with the material in it, and I'll be able to tell you how much of this I actually got. This will be my actual yield. All right, we can do the stoichiometry calculation to calculate how much I should have got from the 0.25 grams. But you can see that based on what's on the table there, the stuff that's spilled out, that I'm going to have a lot less. So my percent yield is going to be really low here on this case. So I've got to consider, how am I going to do this experiment a little differently next time so that I can get a better percent yield? Because your percent yield is your actual yield divided by your theoretical yield times 100. I don't know. I bet I'm probably 30%. All right. So I'll see you later. This is what happens in the lab. It's back to the drawing board. Have a good day.